Greetings. Welcome to the lecture number 4 of ideal gas. In this lecture, we'll learn about Maxwell law of distribution of molecular speed. In the previous lecture, we have learned the Maxwell-Boltzmann distribution law and we have derived that law too. Before we start, we are giving you a warning that if you don't are very much familiar with the volume of a sphere and gamma function, then go and read this because we'll need very much that. And another one thing, the previous lecture is very much important for this, but if you are already familiar with the Maxwell Boltzmann law, then this is very fine, go ahead. We'll find the molecular speed in this spherical cell. Okay, this is the region we have to work with. This is the region dv, so we have to work on this. To work in this, we have to use the expression we already have derived in our Maxwell distribution law. So what is the expression? Let's write down the expression. dn v is can be written as d3 vx vy vz. Okay, this expression from the Maxwell Boltzmann distribution law, we have that expression a to the power 3 e to the power minus b v square dv dx dvx dvy dvz. Okay, this now we are not in this term. This is the volume of this region. Now for an spherical cell, this volume, what will be the volume? That volume term dvx dvx dvy dvz, this volume term for a spherical cell will look like that v square, as the v square, v is the radius, sine theta d theta d phi dv. Okay, this is the volume for a spherical cell. Now one more thing is important, that limit of the theta and phi. Okay, already we have learned in mathematical physics that volume, this volume, how to find this volume. So this can be written as d of nv can be written, v can be written as, look, 0 to the value of theta is equal to, the value of theta is equal to 0 to pi, and the value of phi is equal to 0 to 2 pi. Rest of the things are same, e to the power minus bv square. And now these terms we have find that v square sine theta d theta d phi dv. Okay, look at this term here. These terms are constant, and for the v also constant, because we are considering only these two parameter, that theta and phi. So from this we can write that n a cube e to the power minus v square v square. Okay, and now sine theta, integration of sine theta is equal to minus cos theta, the value of from 0 to pi, minus cos theta, cos pi is equal to 1, and cos pi is equal to also 1. Okay, then phi g phi, the value of phi will be 0 to 2 pi dv. That actually, if we determine this value, we'll get, okay, we have, if we determine this value, we'll get actually what, that n a cube e to the power minus bv square v square, this is 1 plus 1 2, it is 2 pi dv. Okay, these terms actually let us tell n a cube e to the power minus bv square 4 2 this is 2 to 4 pi dv. Okay, now look at the term very much look at the term carefully, that and let's write it here to that n a cube e to the power minus v square dv, uh, 4 pi, that term we have get. Now look at the term carefully. It has two component. One is that for that the curve, if we plot a curve, that will be exponentially decay, and then another term that is quadratic term. For it will be uh, to be that is for increase, and that is for decrease, and both will be look a similar type of curve. But to find this, we have to write an expression d of n v by dv. That expression is 4 pi n a cube e to the power minus b v square and v square. Now draw this curve. Okay, this is the region, this is the v0. Okay, that is dn v by dv area. Okay, look at this term. It has two terms. One that is exponentially decay term, and the term is quadratically increased term. So but for the lower value of v, these terms will be dominating term, and whether when we get to high the value of velocity, that term will be then dominating. So the curve will be look like this. In some here of this is the dv region. This is the dv region. And another interesting fact is that this curve is called Gaussian distribution curve. Gaussian Gaussian distribution curve. Okay, till now we have get a lot of thing. We have find that expression, but look at that expression. In that expression we have two terms, a and b. We don't know about these two terms. Unless we know this value of these two terms, or anything about these two terms, that expression is incomplete, and this expression do not give us a total idea about this. So we have to find the value of a and b. Now let's go to find the find the value of these a and b. Consider all the molecules. All the molecules, considering all the molecules, is actually that d in v. Now we are considering now all the molecules, so the value of it is 0 to infinity. That means all the group of molecules we are considering here. What we get the result of this 4 pi n a cube, now 0 to infinity v square e to the power b v square dv. Okay, these terms we are not bothered about these terms for integration. Only these terms is we are bothering about that integration. Okay, now we have to find that integration 0 to infinite. If you are not greatly familiar with the gamma function, go and read the gamma function, because it will be very much useful to find this integration. Okay, now to find this integration, we have to firstly let this b v square is equal to x. Okay, now 2 b v dv is equal to dx. Also we can write v dv is equal to v dv is equal to 1 by 2b 1 by 2b dx. Okay, we can also write that v square dv is equal to 1 by 2b into, look at this term, we can write it by x by b to the power half dx. This term also can be written as, 1 by 2 b to the power 3 by 2 into that x to the power half dx. Okay, till now what we have find, and now write that expression. Okay, from this 0 to infinity v square e to the power minus b v square dv, we have this. Okay, now this e to the power 0 to infinity. Okay, now for v square is from the value of 0 of v, the value of x will be also 0, and the value of the infinity for v, the value of x is will be also infinity. Now we have these terms, we have that terms is equal to, we can write this term is minus x into another term, we have that v square dv. The v square dv terms, we find this is in like this, 1 by 2 b 3 by 2 into x to the power 1 by 2 dx. Now look at this term, this terms is not useful inside the integration, so we can keep it outside of the integration. 2b 3 by 2 0 to infinite e to the power minus x to the power 1 by 2 dx. Now you can remember this term is look like a gamma function. How a gamma function look like? A gamma function is look like, there a gamma function gamma in is look like 0 to infinity e to the power minus x to the power n minus 1 dx. That is look like. Now these terms and these terms are, both terms are similar. If you want to find it in gamma function, then this n1 n minus 1 should be half. Okay, this n minus 1 is equal to half, then so that in the value of n will be 3 by 2. Now this equation actually that means 1 by 2b over 3 by 2. This term is gamma function of 3 by 2. Another important relation in gamma function is like that gamma n plus 1 can be written is n of gamma n. Now this 3 plus 2 can be written is half plus 1, that can be written is 1 plus half. Okay, the value of n is now half, so that can be written as 1 by 2 gamma 1 by 2. This value of gamma 1 by 2 is root pi, so that is root root of pi by 2. So the value of this is we have is 1 by 2 b 3 by 2 into root over pi by 2. That means that root over pi by 4 b to the power 3 by 2. The till now we get the value of the n. Okay, we till the value of this integration, the value of this integration. Now that we have to work on this total term of n is equal to this. Okay, now let's write down in their page and come back with this. Okay, till now we have this. Now one more thing, this. Okay, we already find that 4 pi n a cube n is that. Now we already find this this thing, that is 1 by 4 b 3 by 2 into root of pi. Okay, we have already find this. Now look at this scenario, that will be cut off, that will be also nothing. Now the terms we can write here is look like that 1 is equal to, or we can write this b to the power 3 by 2 will be is equal to a cube, and the pi 1 plus 1, that is in the value of 3 by 2. Okay, now all the terms have 3, so we can write down the value of a is equal to root of pi root of b by pi. Till now we found the value of a. Okay, but one more important thing, we got the value of a, but the value of a also with respect to b. So we don't have, still now we don't have find anything of this constant a or b, because if the b is unknown, then what we will use of this value of a. So we have to find the value of b2. Let's try to find the value of b2. Now to find the value of another constant b, we will use the concept of average velocity. How? Look, that v square, this is the average velocity. We can write this from 0 to infinite v square dn by 0 to infinite dn. Now this term can be written as, okay, we have find already integration of dn, that is 0 to infinity, and that term we can write as 4 pi n a cube e to the power minus v square. Okay, and also we'll have v square, but another thing we'll had here, that we another have a v square term there. So for this we'll use that v square dv, basically b to the power 4. For there 0 to infinity 4 pi n a cube e to the power minus bv square dv. Now look at the both term here. There are a lot of similarities. These terms and these terms are same. So for the upside downs we have that only 0 to infinity only e to the power minus b v square v to the power 4 dv, and here is 0 to infinite e to the power minus b v square dv. Okay, now one more thing, that already we have find this term before, so we just have to find this term. Let's do it. Now to find the integration, now to now to find the integration of 0 to infinite e to the power minus vv square of v to the power 4 dv, we have to find this integration. Okay, dv, we have to find this integration. To find that integration, we'll do same as we have done previously in that for the v square term. Let's do it again. If you have already understand the previous integration, then pause the video and do it yourself. It will be more efficient for you, and later you can skip the video too. To find this, let that p square is equal to x. Okay, that means 2b v dv, sorry, dv is equal to dx. V square is equal to, we can have x by b, that means v is equal to root over x by b. Also we can have the term of v to the power 4 term 2, that means what, v to the power 4 means that x square by b square. Okay, now this term, and the limit of this for v and x will be same, 0 to, the limit will be same as it is already, so 0 to infinity. Now representing this, can this expression write into the form of e to the power minus x, and for this, and for the b to the power 4 dv, we can write the equation is x square b square into 1 by 2 b x by b 1 by 2 dx. Okay, we have this till now. Now look at this term. These terms we have to little more simplify these terms. How to simplify the term? The simplifying the term is 0 to infinity. We will have that e to the power minus x. Now all the terms of x is calculated, to get it together, 3 by 2. All the terms of b also, uh, all the terms of b also let together, and that is 1 by 2 b 5 by 2 dx. Okay, to now look at the expression. Here we can write it in the form of 2b to the power 5 by 2 into 0 to infinite e to the power minus x into x to the power 5 by 2 minus 1 dx. The term, we again we can remember the gamma function. This is the form of a gamma function, so we can write that function in that way. 2b to the power 5 by 2 is equal to, can be written as this equation can be this integration is the gamma function, sorry, this integration is the gamma function, and that can be written as gamma of 5 by 2. We already have read and gamma function that gamma n plus 1 is n of gamma n. So 5 plus 2, we can write down the 5 plus 2 in the manner of 1 by 2 um, b to the power 5 by 2 into gamma of 3 by 2 plus 1. So that can be written as 1 by 2 b to the power 5 by 2 into that 3 by 2 into gamma of 3 by 2, 3 by 2 into gamma of 3 by 2. Okay, now the now let's we find till now. Okay, now remember what we have done, that these have the two thing to find, that e to that infinity e to the power minus b v square v to the power 4 dv by 0 to infinity e to the power minus b v square dv. Okay, till now we find that both of the integration, the first is the value of this, the value of this is, so how can we write that, that is the basically 1 by 2 b to the power 5 by 2 into 3 by 2 gamma function of 3 by 2. The this expression we already have done this in our previous part, when we have to find the value of a, we have find this expression, integration of this expression, and that was, what was that, and that is 1 by 2 b to the power 3 by 2 into gamma function of 3 by 2. So in that, from this expression, what we have, from this expression we have that will be cut out, that will be omitted, that from this expression we'll have the 3 by 2 into 1 by b is equal to 3 by 2b. Okay, we now actually now we get something, that the value of b we found here. This is how we have found the value of b. Okay, now let's to find the value of b, we have found that v square is equal to 3 by 2, sorry 3 by 2b. So one more thing, 1 by 2 m v square, that is the kinetic energy, that is the kinetic energy we know. This is, that can be written as 3 by 2 kbt. Okay, got it. Now 1 by, from this we can write 1 by 2 m 3 by 2b is 3 by 2 kpt. So we can write here that b is equal to b is equal to, therefore b is equal to, can be written as 3, sorry 2 kb by t. That the expression of b. Finally we get the value of this constant b. Okay, now one more thing, we can find the value of a2. What the value of a2, we find that pi by b, so that can be written as m of 2 pi kb t. Thank you for till watching this, and if you have any problem, you can ask me. There is no hesitation to ask a question. It is absolutely fine to don't know something. Okay, for your convenient and high quality study materials, in form of PDF is attached in our description box. Thank you.